So this is a question from the practice sample for Math League. There, it's under Taste of Math, Volume 9. I think it's question number 9. Student brought this one to my attention yesterday, and so I thought I'd just share the answer here with everybody. Uh, so the question is basically we have this square with side lengths of 1 and 1. So 1 unit, we don't know what unit it is. If it's centimeters, it's not telling us. We just know that it's a 1 by 1 square. So obviously then the area of that square would be 1 times 1, which is 1 square unit. Simple enough. Or I said unit squared. So the question is asking us to find the area of this green triangle right here. It also tells us that each of these sides, this side is bisected, which means it's cut in two equal halves by the tip of that triangle, that vertex right there. And this line right here is cutting this side in half as well. So we know that this is basically a half, a half, a half, and a half. So these segments here are a half of 1. So we're trying to find this green triangle, that area. So first thing we need to realize is that because these are two lines bisecting these two sides, then we're meeting down here at 90-degree angles. So all these angles are 90-degree angles, which tells us that these are right triangles. So this is a right triangle, that's a right triangle, and this is a right triangle. So we need to figure out basically what are the areas of each of these triangles. So if I just kind of think about this big triangle here as separate from the whole thing, I can see that that is half of the area of the square. So I know right off the bat, this is a half of the area of the square. The pink triangle here I can see is a quarter because it's the same as these two white triangles here. And we can see that these two white triangles make one of these if we put them together. So this is a quarter of the area. Oh, that's not what I wanted to do. So this is a quarter. I'll just clone that and then I'll put it back. So this is a quarter of the area of the square. Okay, so the question is, what is just this section right here, right? So that's a quarter, but what about that leftover white space? What fraction of the area is that? And what fraction of the area is this little bit right here, these two pieces that make a quarter? So I'm going to call this bit right here, the part that's white when I move it, I call that B. So this triangle right here, I'm going to call that B. This little tiny one right here, C. So we can visualize here that B plus C makes a quarter, right? So we split like this. Here's B, here's C. B plus C makes a quarter of the area of the square. Now, how can I figure out what the area of each individual piece is here? Well, you need to know a little bit about Pythagorean theorem and similar triangles. So these two triangles here are similar. C is similar to B. And how do we know that? Well, we know that because the hypotenuse of this triangle, if you've done Pythagorean theorem yet, that's the longest side of a right triangle, opposite to your two legs, that 90-degree angle, that's a half. And the hypotenuse of this triangle is 1 whole. So I can see that I'm dealing with two similar triangles that are in proportion to each other, and the side length of this one is double the side length of C. So the side length of B is double the side length of C, which, again, if you know a little bit about similar triangles and area, that means that the area of B is 4 times bigger than C. And if you're not sure why that is, you need to read up a little bit on Pythagorean theorem and similar triangles, and I can certainly help you out with that. But for the time being, based on that knowledge of similar triangles and Pythagorean theorem, we can say that C is a quarter of the area of B. So C is a quarter of the area of B, which means that it would take 5 of these C's to make BC combined. So if this is a quarter of this, that means there's 4 of these C triangles that would make up this area, plus that C right there makes 5 groups of C, would give us that quarter of our whole square here. So what if, based on that knowledge, knowing that C is a quarter of B, then that means that C is a fifth of this whole thing, B plus C. So C is 1/5 of B plus C, the quarter of the area of the square there. So if that's the case, then B must be 4/5 of the quarter. So therefore B is 4/5 of this triangle right here. And so what we can say now is, well, basically, if that's the case, if B is 4/5 of the quarter, well, what is 4/5 of a quarter? I need to find 4/5 of the area of that triangle. So what is 4/5 of a quarter? Well, 4/5 of a quarter, we can do that simply by multiplying 4/5 by a quarter. And again, if you've done multiplication of fractions, you know that that's pretty straightforward. You can cross reduce your 4's here down to 1 and 1, and we can see that it comes out to be 1/5. So basically, B, this triangle right here, is 1/5 of the area of the entire square. So now that I know that, all I have to do is take my half, this triangle right here, minus this triangle right here, a fifth, and that should give me the area of the leftover blue part right there. So I want to go half minus 1/5. And again, if we've done, even grade 7, 8, you've done addition and subtraction of fractions, so you know you need to get a common denominator, which for this one is going to be 10. And that means we need to multiply both of these by 5. So this becomes 5/10. And we need to multiply both of these by 2. So this becomes 2/10. And then we subtract our numerators. 5/10 minus 2/10 is 3/10. So we've discovered that the area of that blue triangle right there is 3/10 of a square unit.